Yeah.
All right. Yep. So today the topic is strings. And actually the last time I led the session, I covered strings as well. So I'm calling this strings 2. So let me share my screen, and if you have a copy of the handout, which I believe should be in the chat, you can open that as well. Let's just get started with the first question. Okay, is my screen visible?
Yes.
Yeah, we can see it.
All right, cool. So yeah, let's take maybe a minute or so to read this first problem, and then we'll discuss. Okay, so I think for this problem, at least the problem statement should be pretty clear. We're given a string and we want to sort it in descending order based on the frequency of characters. So if you look at the first example, the input is tree, and then the output should be EERT because E appears twice. So it's the most frequent character, so it comes first, and then followed by R and T. So for this one, as it says, EETR would also be a valid answer since R and T both have a count of 1. And then if you look at the second example, both C and A appear 3 times. So we could either just return the input as it's given, or we could also return AAA, CCC. So does anyone have any thoughts about how we might go about solving this problem?
Hashmap plus priority queue.
Yeah, that's exactly how I solved it. So Hashmap plus priority queue. So the Hashmap, what does the Hashmap do in your solution?
Store the frequency, and that's the first run. Just update the frequency.
Yep.
And we can use priority queue on that and go in the, max heap actually.
Yep.
And go in a reverse order and fill as many frequency times in a string builder.
Yeah, exactly. So does anyone have any questions on that solution, the heap plus the max heap plus Hashmap?
Do we really need the Hashmap here?
If it's just a low, if it's just a lowercase alphabet letters, array is also good.
Yeah, that was
of 26.
Yeah, okay, that's a good question. So let's see it in the actual question if it specifies. Hang on. Okay, so it doesn't specify the character set, so you can have, it seems like you can have both uppercase and lowercase.
Okay, yeah.
So that, I guess you could still probably use an array, but it might be easier just to use a hash map, and that way you don't have to worry about like the array length and that kind of stuff. So Naga, do you want to try coding this one maybe?
I can, but if anyone wants to take the chance, I let them.
Okay, any volunteers? Going once, twice? Okay, I guess it's, yeah.
Yeah, but before anyone starts, at least I couldn't get that Hashmap. So Hashmap, the key going to be the letter and value going to be the frequency.
Yep. So that the hash map will track the frequencies. And then the problem with just using a hash map is that a hash map doesn't have any notion of ordering based on the frequency just by itself. So we need, like, the advantage of using a priority queue or a max heap is that we can just efficiently get the most frequent character at every step and then build up the string until that priority queue is empty.
Okay.
So Naga, do you want to share your screen, or do you want to like take control of my screen?
I already solved this in lead code, so for me it will be easy. If somebody wants to take a shot, they can try. So say you want to try.
No, because I am still couldn't get the heap part properly.
Okay, yeah, then I can probably share
yeah.
my screen if no one is willing to take care, because it's just.
Yeah, sure.
Let me see. This is a character count. What is the problem number? I don't know. This one, right?
Yep.
Yeah.
451.
I think I already just reset. Okay, so since we know the problem, I'm not going to talk about it. The first thing is build a hash map of char comma count. So I'm using Java. So it's a character comma integer. I call this as a frequency. And I will probably use when looping the characters, we can also just use a regular for loop. I mean, like there is a shorter for loop, but I read somewhere that this s.caret is faster than converting to an array of characters. So now we have the frequency of all the characters. Now we need to use a priority queue of just the characters. We'll call this as maxi.
But should we take a small a and capital A as the same or different character? We didn't clarify that yet.
We don't need to, it's a different characters, because if you see here, the example AABB, they are taking it as a different characters in the third example.
That's actually, it is a little bit tricky example since A and, okay, maybe, yeah, we can consider. If there is one additional A, okay, yeah, that's fine.
Yeah, if they were same, then it's like we could have converted everything to a smaller lowercase and just use a 26 array also.
Because since they are exact same A, they are coming together, so I was like just that confirming that.
One clarification: if we read it properly, in the example 3, it is told that capital A and small a are different. I think.
Yeah, that's what. Yeah, that's what we.
No, it is written also. So first thing is that if we have any, I mean, it is a general advice, right? Read through each and every text if you have a confusion in the question for the late code, because a lot of time they explain in explanation or example, or at the end they give what you think. Or otherwise ask interviewer.
Yeah, because when they're asking in an interview, this is not explicit. It's kind of you need to ask questions to clarify. That is also expected. That's like design questions.
Yeah.
Thank
Agree.
you.
So now to sort it, basically we just need to use the comparator, so which I'm using as a shorthand form. So this is a maxi which sorts by the higher frequency first. Now we need to run through the other loop. So where this is that.
So this is actually something I'm still learning myself. So can you explain the comparator on the priority queue, like the ordering of C1 and C2?
Okay, so if you want to, like, this is just a whatever that you are storing.
Yeah.
So this is a character is a type, right?
Yes.
So,
Yeah.
so this is kind of takes two arguments.
Right.
Like if they, depending on how you want to sort, if given these two characters, I want to sort based on the frequency, which is inside the map dot get is actually
Yes.
an integer. So,
right. So basically, my question is like, how do you know, like, because in this case we want to sort it in descending order, right?
Yes. So if
So
you
how
want
do you
descending
specify?
order, so
Yeah.
basically you need to return a higher number to the comparator. Like if you take integer values,
Mhm.
so if you want to have a descending order, you need to return a positive value, the comparator. If you want
I see.
it to be in ascending order, you need to return a negative value. So
Right.
if the same thing, if you want to return a negative value, you just make this C1 and C2. So whenever some small value is there, small frequency, then it'll push the small frequency to the front always.
So
Okay.
so if we return my negative, 0, and positive, that has a meaning of this. Is that so?
No, zero means it will keep the, I mean, like in the actual sorting comparator, it will keep in the same order.
Yeah. So 0 means
but
both value are same. If we
yes,
return negative, that
correct.
means
Yeah.
C1
It's
are
least
greater than C2. Oh, sorry, C1 is
less
than
than
C2.
C2. Yes, correct.
And if we return positive, then first argument is greater than the second.
Yes.
Okay.
So since it is max.
Sorry, one more question. So I think main question is 1 means will it swap or -1 means it will swap?
Yes, correct. 0 means it will keep as it is.
Yes, but for 1 will it swap or for -1 it will swap?
For both it will swap. I mean, like the concept of maxi, yeah. So it will swap for both. So in this case, the idea of max heap is keep the maximum element in the top right of the heap.
Okay.
So if you're using a sorting comparator, then actually, yeah, I mean, like even for heaps also it will swap internally. But the idea of comparing, so you are telling which one to keep it on the top always. So
Because
in this
confusion
case,
is if both going to swap, then using C1 first or C2 first, not a big difference, right? Because based on the ascending or descending, it has to, am I missing something?
No, I think the question is whether to swap or not. That is, I would say that we should ask the different question, saying
Okay.
that when I compare C1 and C2,
Okay.
which one is bigger and smaller, right?
Yeah.
Now you are saying that C1 is bigger, and if you are returning positive value, that means that goes higher.
Yes.
I mean on the higher in the queue. But if you are returning negative, then that goes lower. So basically, if you say that which one is bigger in that way.
okay,
So
yeah.
With a swap or not, it depends on when you compare to value whether it is bigger or smaller, right? And what you are returning when you're comparing.
Yeah, you can pass this comparator to the sorting function like collection arrays.sort, the same comparator. So it will actually sort in a descending order if you are storing the numbers. But this data structure is a heap, right? Like if you know the heap implementation. So I think if you try to implement the heap using an array, either max or min, you will understand how this works internally. So just use the maxi dot add or offer whatever. So now we have all the items like unique elements in the max heap. So we need to return the result, right? So string builder. Here now we can actually go through the heap while max heap is not empty. So you just pull the current character. Just so actually you need to get the count. So frequency dot get of max heap dot pull. Actually, I think it's good to store this character so we can append this. So now while this count is greater than 0, you can just append character and decrement the count. And I think once you finish, you can just I think this should do.
So Naga, one question I had is like, I thought that we will run the max heap on the count and not the character, right? Like when we create a priority queue, that is a...
Yes. That's where I'm specifying right here, frequency dot get. It actually sorts based on the count. Yeah.
Okay. There is a get of that from the frequency map. Okay.
Yeah, you just store the character, but like its sorting is based on the frequency count in the map.
Got it. Okay.
The priority queue you put in there is the character, right? It does not have, it cannot, would that character, shouldn't that be a map entry if you want to get a count?
We already are storing the count in the frequency map, right? Why to duplicate it in priority queue?
Oh, okay.
I'm just looking up when actually polling from priority queue. So getting the count again from the map. So it's just to have the storage less. If you are storing the count also here, that's also fine. But in that case, you don't need to look up in map here. So you have the pair here, like character comma count. Any questions on this?
So going back to the way we define priority queue, which takes C1, C2, right? So C2 is the incoming value.
Yeah. Both C1 and C2 are incoming. I mean, like this is like if you are writing a custom comparator, comparator of character comma character. If you are writing manually, so this is how I think you normally write in Java, I think. So you just do all this, and then here you override some comparator method, I think.
Right.
So, sorry.
Yeah.
You override and just say public int compare. I think I don't remember the syntax currently, but here also you accept like C1 and C2, and then you return the actual compare result, right? So this is just a shortened form of that.
Yeah. My question was like in line 19 when we do like whatever line 13, we do max heap dot add, right, and add of a new character. So
yes.
At that time we are just passing one input parameter to that max heap, right?
Yes. So I'm just using the keys. So basically only the unique characters will be added into the.
Yeah, exactly. So what I'm saying is that once we added the first element to the max heap, right? So that first character The loop goes first. So does it go in C1 or C2? That is what my question was.
Oh yeah, I think for the first item, the both will be the same. So it just gets added and does nothing. So
And the second time, what happens in the second time?
Second times it actually checks like it actually runs this. It actually internally does this compare on the internal items. So basically, it depends on this priority queue implementation. If you are adding something, you normally, if you are using an array implementation, if priority queue is normally you are just saying A, B,
Yeah.
C,
So I think the C2
D.
will have the new character, whatever we are adding, right?
Yes,
and the
yes.
C1 is like the existing characters in the heap against which it will do the comparison.
Yes. Internally, if you are adding D, so by default it will be added into the towards the end if you are using an array comparator, and then it just checks against its parent. So that added element and its parent is compared. So those two are actually passed to C1 and C2. Not everything. So if it's an array, each element is actually compared with most of the other elements. But in priority queue, I think only the element which you are adding will be compared with the parent and its parent. It goes to the top. So every time it's just log n comparisons.
Right. Yep.
So Naga. So one question. So like your comparator depends on an external data structure, which is the frequency hash map. So
Yes.
let's say like maybe this is outside the scope of this problem, but let's say if you make a priority queue like this, and then let's say that you make some change to the state of your frequency hash map, like you change some of the frequencies of the characters.
Yeah, that time it doesn't automatically update the priority queue.
So you'd
You're
need like
making some changes to the hash map after adding to the priority queue. Then it cannot automatically refresh by the frequency.
Right, but
so that's one disadvantage of this.
If we did instead, if we did map.entry and then stored the key value pairs
here.
Yes, so in that case, the state would be completely contained in the priority queue, right?
Okay, you are okay. So you are saying that if you do the map.entry here,
yes,
and use the same map entries in priority queue.
Yes.
Is that what you are saying? Okay.
Yeah.
So in that case, if you update map also, yes. Yeah, that makes sense.
I'm actually not sure about
so
if it would work in that case.
In either case, right? What we are expecting, if the entry in the map update, will it not affect the priority queue?
Yes, is there some way of like avoiding to like resort the priority queue? In other words,
so once it is added, it won't resort.
Okay.
Yeah, that's what.
Okay,
yeah,
I see.
Yeah. Once we are past for loop, it will even if you change outside, it is not going to affect.
Yeah,
okay, I see.
Yeah, the heap will stay the same. Yeah, so I think for those scenarios, you need to use indexed priority queues.
Yeah.
Or a tree map is also, I think, does a similar thing. Map can also be used sometimes wherever index priority queues can be used.
Oh, what is that tree map now?
Not tree map.
Tree map. Oh, okay.
So yeah. So
okay,
the tree map
sure. Okay.
class, yeah. So there you can get the least and greatest keys like easily. I think internally it implements red black tree or something, which always returns in login.
Cool. Yeah, do you want to just discuss maybe the time complexity and then we can wrap this one up?
Yes, the time complexity is linear to the length of for a hash map, it will be the string length. And for the heap, it is the, okay, let me update somewhere. So if n is equal to number of characters or like string length. Maybe we can just say. And if k is equal to the unique characters, yes, then I think it is big of n plus log k.
K log K.
Yes, for n items. Is it n log k?
K log
K, right? K. I
K,
think.
k log k, yes, correct.
If there are k items, right?
K unique characters.
Yes.
Yes.
Yeah, I think that makes sense.
Yeah, that seems right.
So one thing I had, like, I think somebody mentioned about the approach, or I think Naga called out that we can take a list and then we can, I mean, the other way to solve this problem is you take a map as well as the list, and then you write a custom comparator for the item which you are putting in the list, right? And then you call the sort on that. So that is one of the another way to doing this, which is internally using, I think, the priority queue only. But I just wanted to discuss a little bit about the complexity in that scenario. So we end up using like list and map.
So you are saying like list of characters and list of char.
Yeah,
And
I think someone posted
so,
in the chat, like I think he did. If you're referring to the same thing, I think he had a linked list of map entries.
List of some class, yeah, like a class which has like a character and a count, and that internally implements the comparator class, which overrides the comparator function and then writes the priority queue there.
Yeah.
yeah, maybe you can just, do you want to explain that, or like?
If I understand correctly, so the complexity will be same.
Yeah, it should be same.
Yes, I think that solution is posted in the chat, I believe, by Somas.
Because only difference is instead of priority queue, it's going to contain in the list. Anyhow, the list needs to be sorted for all the unique character. If unique character count is k, then definitely sorting is k log k, right?
Yep.
Yep. Cool.
List of map entries. Okay.
Yep.
Yep. So
Question. So one last question is: Can we improve that complexity even further?
I think since you need to sort, I mean, like in some other way, like from higher frequency to lower frequency. I think this is, I don't know if we can do better than this.
So
yeah, and I think you'll need ON at least to capture the counts.
Yes, and to be able to do like the reverse counting, I think this is needed. Place the minimum. If anyone has better approach, I think it's good to learn.
So I was thinking, again, it's a complex data structure, but if we use most frequently used, so the version of least frequently used, cache, and then convert it to the most frequently used. And in that case,
So you basically there also you use a hash map linked list, or
no? There we use a doubly linked list and then other extra map to point to the list.
Yeah. So if you are using construct a hash map, you need
ON. We can't improve ON. But we can just cut down the k log k to just k.
But
how do you? But every insert or update, you need to keep swapping in the doubly linked list, right? Like there will be a lot of add remove operations.
So
or move operations to the file.
Yes, every update you move at most one, because you found one character later, higher, right? So either you move from current bag to the next bag. Suppose the character count was 5, and then you say that its frequency is 6. So it remove from the current bag and go to the next bag that is 6.
And that remove operation, since it's a double linked list, it will be constant.
Constant. Yes. Yeah. So it's a more complex implementation, but I just to make the point saying that we can cut down k log k to k, so then we can say that it will be of an complexity.
So in the doubly linked list, you just maintain the unique characters, right?
Yeah. So I mean, I think it is not just doubly linked list. Basically, doubly linked list is the one that maintain saying that count 5. What are all the characters are count 5, and then count. It just maintain a map. Or a set.
So this is kind of count comma list of characters.
Or set of characters. Yes. Set of characters. Now and then there is another. So we are just going into implementation, but there is another hash map that says that for this character, what is the linked list node, right? So when you found a character, you basically go to that linked list node and say that you are in the 5. Now you increase it to 6. So you move to the next. If 6 is there, then you basically add into the next. If not there, then create that new node with the 6 count and do that. But basically, it's a constant cost.
Memory wise, it adds more memory. But like it's complexity wise, it's less.
Exactly. Yeah. Okay.
Yeah.
So Bhavesh, you will not create the map in this case. Like you will like
the
map
will be there, but the here right now in the map we are keeping the value as a frequency, but instead of frequency, what he's suggesting that we will keep the reference to the linked list node.
I think as far as I understand, we need 2 hash maps and 1 doubly linked list. Is that correct, Bhavesh?
That's correct. So yes, if you go into implementation, we need more data structure there, but we improve on complexity basically.
No, just one map and 1 doubly linked list should be enough here.
No, 1
maybe possible.
Also.
Let's let's not go into detail, but I mean it's a implementation of LFU or MFU, right? Maybe it is possible with 1 map or 1 linked list. Probably whatever I have seen, it was different. But yes, nevertheless, if we use that, probably we can improve the complexity. That's the only point I want to make.
Okay.
Right.
So
it makes sense.
So for the current implementation, the complexity can be n log n in worst case, right?
Yes.
That's correct.
Okay.
If k is n, then n log n.
Yeah. Okay. Sure.
Okay.
We can move.
Yeah. Good discussion.
Okay, I'll stop sharing. Maybe we can move on to.
Sure. All right. So I'll share my screen again, and let's take another minute or so to read the next question. Is it visible?
Yeah, we can see it.
Okay, cool. Okay. Okay, so this this problem, in my opinion, it's a very interesting problem. So first, let's just make sure, does everyone understand the problem? So basically, we're given a list of, I guess you could say, words, and the problem is to find the maximum length concatenation of a subsequence of the list of words where all of the characters are unique, and you want to find the maximum length concatenation. So if you look at the first example, these are all of the possible concatenations which have unique characters. And so the longest length will be 4, which represents either UNIQ or IQUE. And similar with the second example. But the concatenation it can be a combination of any of the characters or any of the elements in the input, so long as the concatenation is has all unique characters. So is the problem statement clear?
Could you please explain the second one? Because I thought it should be CHAR should be also one of the candidates, is not it?
Right.
But
so
it's less length, I think. Yeah.
Right. CHAR will have a length of 4, whereas these two have a length of 6. Yeah.
So
okay.
For the first example, can we take an IQUE?
No. So you have to use the entire word.
Oh, entire word. Okay.
Yeah, the entire word, and another important thing is that it's not just all combinations of 2 elements or 3 elements. It could be any number of elements. So if you have an input with all unique characters like A, B, C, D, E, then you could use all of them in the output and output the length.
Yeah, and another important observation, they clearly mentioned subsequence. So you cannot pick the last word and the first word as a reverse combination. It has to be always from the first to going forward, right? If you say subsequence.
Yes, that's another good point. So you can't change the ordering.
Yeah, you cannot say IQUN. It should always be UNIQ. Yeah.
But it doesn't matter, right?
You have to just.
I mean, for the length perspective, it doesn't matter. But I think when you're calculating, I think if you start considering from IQ, you should only look UE and not look backwards. So that's my point. Just to
okay, what I'm saying is that, see, the answer is ACTERS in the last one, and CHAERS, right, for the second example. Now, whether we take ACT first and CHA later, I mean, answer wise, I'm saying that it is not gonna change anything.
That's true.
In the order.
But our logic will change, right? If you have to consider previous elements, our logic is checking all the, I mean, for each word, you're again going back and checking the previous index elements or index words, which is not necessary. That's what you might have already considered when you tested with your first word.
Maybe in the second example, the last word, if you take ERSC, then that cannot be merged with the previous word ACT, since C is repeating. But at the same time, even though it is 4 character, it cannot be merged with the CHA to get the longest string, I believe. That's what Naga trying to explain, maybe.
Yeah. So in a simple way, if interviewer extends the problem to return this sequence, the actual sequence which represents this 6, then in that case, if we go with, I mean, if we have a logic which takes the previous index words.
Okay.
Yeah, so I think also implementation wise, going forward direction
Yes.
only is like probably easier.
Mhm.
Okay, so there's actually a lot of like interesting theory behind this problem. I believe pretty confidently that actually this problem is NP hard. If you're familiar with like the P versus NP complexity classes. So meaning that there's no polynomial time solution for this. So let me just discuss a little bit about that. It's maybe a little bit more depth than we'd need to go in an interview, but I think it's still interesting discussion. So first, like, let's just to review, let's talk about the P versus NP problem in computer science. So this is like a very famous open problem in computer science. And basically what P and NP are they're like sets of problems. So P is the set of problems that you can solve that can be solved in polynomial time, meaning like O of, let's say, n squared, O of n cubed. So this is like the class of problems that most of the problems that we discuss, like in interviews or in lead code, most problems fall into this category because we can solve them at least in polynomial time. Sometimes we can do better, like with logarithmic or constant time. And then NP. So this is something called non-deterministic polynomial time. So basically, this what this set is it's the set of problems that can be verified polynomial time. So you probably won't be able to solve it, like depending on whether or not P equals NP. Like there's probably no way of solving these problems in NP in polynomial time, but if you're given like a candidate solution, then you can at least check that solution in polynomial time. Okay, and so the like big question is whether or not these two sets are equal. And then a subset within NP of problems, it's basically like considered the hardest NP problems. It's called NP hard. You could think of these as like the hardest problems in NP. And they have this property where if you can solve, sorry, just a second. So if you're not speaking, please mute yourself. So NP hard is, you could think of as sort of like the hardest problems in NP, and hardest meaning that if you could solve any problem that's considered NP hard, then that would, if you could solve it in polynomial time, then that would be basically equivalent to solving this P versus NP problem. So I claim that this problem is actually an NP hard problem. And to show that, I'll show that it's equivalent to a well-known problem which is known to be NP hard. So this is called the independent set problem.
Hanif, one quick question.
Yeah, sure.
So when you say NP, when the problem can be solved in polynomial time,
yeah,
and NP says like the problem needs to be verified in the polynomial time.
Yes.
Aren't they like kind of same? Like when you're able to solve the problem in polynomial time, you could also verify using the same thing in the polynomial time, right?
Well, they're not the same thing. I mean, the big question is whether or not it's the same thing. Like whether if you can verify, like for a given problem, if you're, let's say that you're with this problem, right? If I go back, sorry, this thing pops up. Yeah, so if I give you some candidate solution to this problem, you can quickly check whether or not, like you could say, at least you could verify, like you could see if the problem or if the string has unique characters. Like you could very quickly eliminate like wrong answers at least. But in general, these like problems that are in the set NP, like they usually have an exponential solution, and there's no, if you could find a polynomial solution which solves like in every case, not just like checking one particular solution, then that would mean that these two are equivalent.
Okay.
Yes.
NP
So
hard, anything that cannot be verified in NP.
yes. So NP hard, you could, this diagram might be helpful. So the set, so these are all like sets, like sets of, I guess you could say, problems, right? And so there's like two possibilities, whether P equals does not equal NP or P equals NP. So NP hard, you could think of as like, there's some overlap with NP, but there's some problems in NP hard which are like even harder than the problems in NP. I think it's also an open question whether or not NP and NP hard are equivalent. But basically, you could think of NP hard, let's see, as at least as hard as the hardest problems in NP. So since these are the hardest problems, what that means is that if you could solve any problem that's considered NP hard with a polynomial time algorithm, that would basically mean that all of these sets are the same, and that would be this case where P equals NP. Yeah.
Okay.
So anyway, so to show that this problem is NP hard, basically what I'll show is that it's equivalent to a very well-known NP hard problem, which is this problem, the independent set problem. So basically, an independent set, like just think of a graph. So you have some vertices and you have some edges between the vertices. An independent set is basically a set of vertices where no two vertices share a link or share an edge, right? So if you pick just like some random set of vertices in the graph, no two of them can share an edge. That's the definition of an independent set. And then the problem of finding the maximal independent set is to find the maximum size subset of a graph where that subset is independent, meaning that no two vertices in the graph share a common edge. Okay, so is this problem clear, the independent set or maximal independent set problem? So you could see that it says here, it's an NP hard optimization problem. Now, if you take this problem and, so I'll just ask again before we like add anything to it. So does everyone understand the maximal independent set problem? Like the problem statement at least?
Yeah, can you explain again, like how is that max? Like you're just trying to find two vertices.
Yeah, so if you find, like, just consider like subsets of this graph, right?
Right. Just
and
like,
let's say if I take this node here, if you could see my pointer in this node as our subset, this would not be an independent subset because they share an edge.
Yeah.
Right, but if I take like this node and then some other node like here, those are my two nodes in my subset, that would be an independent set because they don't share like a direct edge. So finding so that would be an independent set, but it might not be the maximum independent set. The maximum independent set is the maximum size set, like maximum size meaning maximum number of vertices, all of which do not share a common edge.
All of which do not share a common index. Okay. Is it total or maximum? It can only have like one thing, right? It cannot have like minimum and maximum, right? If you take this set, there could be only one set which are like independent set, right? One maximum. It can only have like one total independent set. Like
that I'm not sure if the maximum is unique or not. Maybe you can, I think you can have multiple unique ones if you think about the problem we're discussing. Because this can, if you think about this one, this can have multiple solutions. And I'll show in a second that this problem, like these two problems are equivalent.
Okay.
So I think you can, it's not necessarily unique. But if you take, okay, so we take, this is like the base level, right? Now, if we take this problem, the maximum independent set problem, and we just add another layer to it, instead of let's keep the same definition of independent. Independent means that. So okay, we're discussing maximal independent set. So independent here means that no two edges, or sorry, no two vertices share a edge. Okay, so we keep the same definition as of independent, but then let's change maximal a little bit. So instead of the maximum number, let's say that all of these edges also had, sorry, all of these vertices had a weight, right? So like maybe this one has a weight of 1, maybe this one has like a weight of 10 or something. So all of these vertices will have a weight. And then the maximum independent set, so this is, so now it's the maximum weight subset.
Yeah. If it has
add
a
up
weight,
all,
yeah.
adding up all the weights of the vertices in the set. So this is a variation of this problem. It's basically called the maximum weighted independent set. Okay, so this is also NP hard because like the underlying problem is NP hard. We just added like another layer to it, basically based on the definition of maximal. So it's also an NP hard. Now, this maximum weighted independent set problem, it's directly equivalent to, if I go back to this problem, because think of all of these words in our input as a vertex, okay? And then think, let's say that 2 of these words share an edge if they share a common letter. Okay, so then this problem, you see it becomes, and then think of the weight of every vertex as the length of the word in like each of these words. So like this CHA will be a vertex with a weight of 3. R will have a weight of 1. So the weight is the length of the words. And then the words in the graph, they'll share an edge if they share at least one common letter. So like CHA will be connected to ACT.
Yeah.
So then this problem becomes exactly equivalent to the maximum weighted independent set problem.
Yeah.
Okay, so that's
total count of characters combining the 2 words. Right?
Yes.
Right.
And it's the maximal one, maximal subset. Okay. So that's kind of like maybe like an informal proof that this problem is NP hard. So it's kind of funny actually. Like it's actually a very commonly asked question by like at least one company, and it's kind of funny to me that they ask a problem that is NP hard, because usually like when people, so basically what this means is that like you're not going to find a polynomial time solution to this problem. If you find a polynomial time solution, then that would be the equivalent of solving P versus NP, and then like probably you would never have to interview again, because
would it still NP hard if the size of the array is small?
Yes, because it's like, just consider the NP hardness doesn't really have to do with the size of the input. It's like more like just the input can be arbitrary, right? Like it can be any length.
Yeah, when you say size of the array is small,
I mean the length of the array, right? If it, let's say if it 2 or 3, the size of the array is only 3, right? Then I think it the brute force will.
Yes, of course. If you restrict like if you have some restriction like that on the input, where, then yes, then it could be easier. And in fact, this problem, if you look it up, there's like it's I guess it's a somewhat like famous problem in computer science research, and there's a bunch of papers, if you like Google this, that try to find like polynomial time solutions for a very specific subset of graphs. So like, I think I have a paper here. So this problem is a linear time algorithm to compute a maximum weighted independent set on co-comparability graphs. So I don't know what this is, a co-comparability graph. But if you just read the first sentence, the maximum weight independent set problem is a well-known NP hard problem. But then they take some special case of graphs which like have some special property, and then they can solve it in like O of n squared or some polynomial time. But the general problem is an NP hard problem. So yeah, so that's just the discussion of the complexity. Like whatever solution we come up with, it's very unlikely that we'll come up with a polynomial time solution. So it'll be some sort of an exponential. So I'll just say that like right up front, so that we don't spend time like trying to optimize the.
So could you explain again why is it NP hard?
Yeah.
Because it just seems like we can solve the problem in the following way, and see if you can find the flaw. I posted an outline in the chat. If you created some sort of a map n by n, right, of all the strings, and you compare each of them with respect to each other, in n over half steps, you can find whether one has the same characters versus the other. So that's all n over 2 steps, right? So O of n for whole practical purposes. Then you create the concatenation of strings that are not unique, that they have unique characters with respect to each other.
Hang on.
So that's again O of n steps. Yes, I'm here.
Yes, so you have to consider every single possibility, basically the power set of the set, right? So that's already, if you consider every possible subset of the input, that's already O of 2 to the n.
But we're not mixing the strings. We're only concatenating them with each other, right? So if we have
But you have to consider all possible concatenations.
Correct. So that's going to be n squared over 2.
Why is that n squared? It's 2 to the n.
Why is that 2 to the n? Because we concatenated the strings. We're not mixing the characters within the string, right? It's a concatenation. So it's going to be four strings on the x-axis in the matrix and 4 characters down on the y-axis in the matrix. And you remove part of the matrix completely. So
but why? But so what are your? Okay, maybe we should. Just in the interest of time, I want to actually solve the problem. But can we can have this discussion after, like maybe after the
Sure.
session?
I just don't think it's an NP hard problem. I mean, clearly.
But I agree.
Any other takers?
Yep, I believe like
still I feel like it is 2 power n only, because even if, for example, if we try to create or find the combination of instead of this actual string, just replace with character like A, B, C, D. If you want to find all the combination, then it will be 2 power n only, right? A alone one time and B alone one time, then AB will be coming one combination, and then you have to replace these things with again next set. It will be definitely 2 power n, right? Complexity, how it can be combined with the n square.
It's not 2 power n. I mean, effectively, you have forget about the fact that they compose of characters. You just say objects, right? And you have n objects, and you just need to figure out whether an object is the same as some other object, which means you're not going to concatenate it with that object, correct? So you have n of them. So you can have n squared possible combinations.
That's n choose 2, right? That's only if you consider every pair. But this
correct.
Is not,
then you combine the pairs, and then you repeat the process. So in each step, you have n squared over 2. And as you keep combining,
sorry, just a minute. By using 3 characters, how many combination you can create? Is it 8 combination or less in your case?
Hey, like I want to like point out like something here. See, there are like 2 things which are given in this question. One is we are only considering lowercase characters. So what if an element in this array just composed of 26 characters A to Z? What should be the answer in that case?
Did you say one word with all the letters A through Z, or like
yeah, like let's say like in the second example we have additional word at the end which composed of 26 characters A to Z.
26, right?
Yeah. So the answer will be like 26. It cannot like we cannot have like any word which can be greater than 26.
Yeah, that's a good point.
Okay, and also like the one additional constraint which is given in this problem is it should be a subsequence. Okay, of array. So anyway, like if we start with the first element, we have to move forward to keep looking for next word and compare like we are not having any words with we are not like picking any words which contain a character which we have already seen. Correct?
Yeah,
yes.
repetition is not allowed, yeah.
So I believe like this can be solved like in n square time.
I think it might be more than n square, right? Let's see for the second example, right? Let's say suppose if you compare the first word with the second word, and then you think that's a better option, but it turned out that the first word with the third one would be the better option. So you miss that.
Can I like share my screen? Like I just have like something in mind and then see like if it is valid or not.
Sure.
Okay. Just give me a sec. Again, I might be like completely wrong, but I just wanted to like give it a try.
If you are not super confident, maybe can the Hanif complete the logic first and then discuss?
Sure, like we can do that too.
Yeah, first, so that we will get more clarity like how the problem gets solved.
Sure.
Then maybe it will be a better discussion point.
Yeah, we try to optimize it.
Yeah, that's yeah. Okay, so yeah, this I want to have this discussion with both of you guys. So let's just put it on hold, and then like let me just at least show a working solution, and then we can see if it's basically the question is whether it's actually NP-hard or not. So yeah, let's first just solve this. So basically, if you think, what would the brute force approach be here? And maybe I will use how do I use the whiteboard? I have to stop sharing my screen, right?
Yeah.
Maybe the brute force is create all combination and get the length. If there is any duplicate, ignore. Try to maintain the max, maybe.
Yeah.
So they draw a tree. I think they draw a tree the first word and then
exactly. So it's, you could think of it as like a backtracking approach. So basically, for every word in the input, you have the choice of whether to include it or not in the final output. So let's consider the first one was like you. Yeah, sorry for the bad handwriting. I think the words were U, N, IQ, and UE were the three words in the input. So for each of these, you have the choice of whether to include them or not. So like if you consider like a tree, let's say that the root is UE. So you could either include UE or not in your final output. So like, let's say that this branch is the branch where you include UE. Right, so far we have UE here. And then at the second level, since the second word is IQ, we have IQ. So in this branch so far, and of course I have the choice of whether to include IQ or not either. So if you consider these four leaf nodes, I'll have UQIE here. And then if I include UE, and then I don't include IQ, I will have just UE. For this element right here, I don't include UE, but I include IQ, so that would be IQ. And then finally, I'll have the empty string here where I don't include anything. And then similarly, like I'll just draw the complete tree. I have the choice of UE at each of these nodes. So if you consider this path, the leftmost path, that would be, sorry, this should be UN. Okay, so this UN, second level is IQ, and then third level is UE. So the leftmost child here, 3 levels deep, this will be the concatenation of everything UN plus IQ plus UE. So maybe we had more, like more strings in our input, like whatever they are. So at this point here, when we have UN, IQ, UE, this word contains a duplicate. So we can kind of kill this branch of the tree, or in other words, prune the tree here. And then so on. So does everyone understand what I'm like displaying here with this tree? Basically at every level of the tree is one of the input words, and then I have the choice of either including it or not. And if at any point I find that the word that I'm building has duplicate characters, then I don't consider anything after that, because that would be just a waste of time. Right? So this will be also to the n. But it's a little bit better because I'm pruning. It's a little bit better than just the brute force because I'm pruning like the things that I don't need to consider. And then the other optimization that I have for this problem is, so we have this core subproblem of how do you know that a string has all unique characters? Right, so let me go back to my screen. Okay, so we basically we need a way to maintain, like how do we determine if a string contains Okay, so one way is just brute force. Check every ij pair. So this will have a complexity of n squared. I'm just going to go through like a bunch of different ways. Another thing we can do is sort the string and then do like linear sweep. So that will be, depending on how we sort, like probably like O of n log n. Another thing we can do is we could use like a hash set slash like some sort of a lookup table, maybe like with an array of length 26. So this one will have, we could do it in linear time, but it will also be O of n space. And then the fastest or the most efficient way that I can think of, just comparing two strings to see if they have unique characters, is using a bit set. So this will be O of n time and constant space. And just to explain, so that's the approach that I took with the bit set. And just to explain that approach a little bit more. So we're given in the problem that, let's see. Yeah, let me. So we're given that, if you see here, the array will contain only lowercase English words. So if you take like a 32-bit integer, every bit can basically represent, it'll be a 1 or 0 depending on whether we have that character or not in the string. So if the string is like A, B, C, D, the easiest way would be to have the least significant bit represent A. So we'll have basically 1, 1, 1 and a bunch of zeros before. This would represent A, B, C, D. And then if we have another string, like let's say like D, E, F, then let's just say it's just D. It'll be something like this. And then we can just take the bitwise AND of these two bit sets. And if that bitwise AND is greater than 0, then that would mean that the two strings have a character in common. Okay, so like basically my approach to this problem was, you could say it's like backtracking with pruning. So this is like eliminating the like duplicate branches. Basically, like in that tree that I drew earlier, I don't consider any branch after I have after the string contains duplicates. And then the other optimization is bit sets to maintain uniqueness. Okay, so I won't just, since I have the code here, I guess I'll just share my code. Basically, for the backtracking, I have this like backtracking helper function. Basically, at the beginning of every call to this function, I just check that it has unique characters, and then my has unique characters function is doing the bit manipulation or like the bit set check. So just to walk through this function real quick. So I pass a string and I have an int check, which is initially 0. Then as I loop through my input, I check if this, if the character or if
Hanif,
the check, yeah.
Quick interruption. Can you increase the font a little bit if possible?
Yeah, sure. Is that better?
Yeah.
Yes.
Okay, cool. Right, so I'm just explaining how I do the bit set to check that string has unique characters. So I have a check, which is initially 0. I loop through all the characters in the string. And basically I take 1 and I left shift that by this amount, C minus A, right? So this will, like, C minus A will basically be like the position within the bit set. So like A minus A equals 0, B minus A equals 1, and so on. So I left shift 1 by that amount, and then I take the AND of that with my check. And if that is greater than 0, then I know that there's a duplicate, so I return false. Otherwise, I now have to set this bit to 1 in my check. So I do that with the bitwise OR. And then if I make it through this loop without returning false, then the string has unique characters and I return true.
Sorry, if the C value is Z, there'll be 26 left shifts?
I believe it'll be 25.
Yeah.
Yeah.
So will that work? It's int, right? Size of int is what?
Size of int is like 32, I believe,
32.
right? Or
Okay.
32.
Okay. Yeah. Okay.
32. Yeah. Yeah. So that's why it's an important point that the string only contains lowercase English letters. So there's like so that everything can fit in like just an int. So that's the first thing I check. And I have to check that like, because basically the way that they gave the test cases also is like some of these words will contain duplicates. So you have to check for those. But basically, so if I make it past this point, then the string that we have so far, it has unique characters, so I can try to update my max, which I've just left as a global variable just to keep it simple. But stylistically, probably you shouldn't use global variables in an interview. And then, so my base case, so this is a recursive like backtracking algorithm. So my base case would be where if you look at all of my parameters, I have this index. The index is the index of the word in my word list that I'm currently considering. So if that equals the size of the word list, then I just return because I've explored everything. Otherwise, I have 2 branches. Basically, this is the one where I explore the possibility of including the word at index, and this is the one where I don't include. So in the branch where I do include, the first thing I check is if including this word will violate the uniqueness. Like if this concatenation contains duplicates is what I check here. So I just take the bitwise AND of current bits, which is like the bit string of the current string, because I have the current word here as a string builder, and then I also have the bits in an integer. So take the AND of that with bits of index, and then bits is a list of integers, which I build in the beginning. And basically this is like a bit set for every word in the input. So this bitwise AND should be 0. And then if it is, I do the OR to combine the like new bits is the combination of the bits of current and the word at index. And then I do the backtracking, and then basically I just undo the backtracking afterwards since I'm using a single string builder. And this is like kind of a standard template for backtracking. Like you consider this possibility, and then you sort of undo that like that decision that you took when you after you explore. So this is the case where I explore the possibility of adding the current word. And then this is the like the right hand part of the tree where I don't consider the current index. So this is like an exhaustive search. And then this this is the part where I'm pruning the duplicates. And so after I do this, the max will, the max should be the global max of what we want, which is the max length of the concatenation. Does anyone have any questions on any part of the solution here?
So initially the current bits will be set to the first word bit array, right? When
Yeah,
you're calling backtrack.
Yes, so current bits initially will be
okay.
0. Yeah.
Why is it 0? Oh, because you are considering from 0 itself. If you are passing 1 here, then you would have passed
Right.
for the first character. Okay.
Yeah, yes.
Mm-hmm.
Any other little questions? So if I submit this, yeah, good. That's basically like the solution. I have a different solution that like defines the backtracking a little bit differently, which is a little bit faster. I think it's the one here. It's more complex though, so I don't want to go into that one. That one's a little bit faster. It was like in the like high 80th or so percentile. And yeah, so I don't know how like much you can trust these percentile like metrics. Like I don't know if it's like a good metric or not, but you don't need this bit manipulation stuff to solve this problem, because as we discussed, you have like all of these different ways that you could solve the uniqueness problem. But like adding that element like greatly increased the
space complexity. So now your memory is optimum.
Yeah.
Can you explain the like has unique characters? Like what's the use of this function?
Yeah, sure. So we have to, like, based on the problem description, we have to, like, we don't want to consider words that don't have unique characters, right? Because that'll be a wrong answer. And we also don't want to consider them in our backtracking, because then we'll be like there's no point, right? We want to just eliminate all of the branches of the tree that we had earlier that contain duplicates.
So like when we're combining, and then we are checking if they have the unique characters or not.
Yes. Yeah. Do you want me to like walk through this part again, or are you asking like how am I?
Yeah, and since you are checking the unique character part in 30th line, right? Like whether it has duplicate.
Yeah.
So that's to construct the word.
Yeah, so there's probably a way that I could have like compacted this a little bit, where I combine these two.
Yes, that's what I'm thinking.
Yes.
I was thinking like on the same line, since you already calculated the bits for the input array. Okay.
Yeah.
And then like if you take two words and possibly do the end of those two, and if it gives you 0, that means they doesn't have any unique word. Like they have all the unique words.
Yes. Yeah. So that's what I'm doing here. But so if I remove this, the problem is, like, you could do that, but you'd have to do some things a little bit differently.
The else part I think we'll get now. Yeah.
You need to add one more check there before like considering that in the backtracking, you need to add one more check.
Yeah. Or like another thing I could have done is, if like when I'm in this get bits function, that's where I initially create the bit set for every every string. So because the problem is that the input that they give you, like the individual words can contain duplicates. So here, if I put some marker, like, I don't know, maybe like in max value or something, that indicates that the current word, like the ith word, has duplicates, then I can probably avoid this call also. Because that's basically what this is doing. It's just eliminating the
like a set. No.
Maybe you can put like -1 in the integer position where you see like if it has a duplicate.
Yeah. I could do yeah. Conceptually, I just wanted to separate the two things just for explanation, but that's true. I could definitely like shrink this down to just one.
It makes sense.
Yeah. Any other questions about this?
So how would you prune it? How would you prune it if there's a duplicate sequence of word?
So yeah, so if there is a
for
duplicate,
example, yeah.
If there's a duplicate, then this and will not be 0, because like two of the bits will, like the same position will be 1, so it won't be 0, right? So that's why I check. I only go in here if it equals 0. So I eliminate the I never check the possibilities where there's a collision or like a overlap.
But you still check the backtracking on line 36.
Right. So line 36 is a different thing. So remember, there's like two branches here. This branch on line 33 is where I consider the word like at the current index, and then this one is like I'm not even considering the current word, so I just call index +1. So but basically, this one I'm just skipping over the current word.
Yeah, but I'm thinking, what if the input, like example 1, right? We have an array with 3 words, right? What if we append exactly 3 words to the end of the array, right? So after the last word, we will have UN and IQ and UE again, right? So if we have that kind of duplicate, how would we?
Right, so that, you're saying if the input, if like one of these words had duplicates?
No, yeah, the 3 of them. So let's say we have an array. Now we have an array of 3, right? Now we have an array of 6, but the last 3 is the same as the first 3.
Oh, okay. Well, I would still get the same answer as 4, because when I get to the first duplicate, I like, depending on what current word was in the backtracking, I just wouldn't consider that word.
Yeah, the bits will be merged, right? Like he's doing an OR operation on, like if they are different, and if they are same, that condition won't pass through. Like the if condition, if current bit and bits dot get index.
Yes, it passed through, but it still implement line 36, right?
No, so it will again come back and still fail in that, because the bits are again same, because those bits are already present in the current bit. It will keep calling and again fail in line 30 for the subsequent calls. Eventually the index will go to the last words dot size, and it will terminate in 29 without any result.
So going back to like the discussion about complexity. So now, do we want to revisit that? Like whoever was saying, like you think you have a n-squared solution?
No, I was saying that, but like I was missing the backtracking part.
Okay, what about the other guy? I think you posted in the chat. Anyone else think they have?
All optimization would be to, instead of the string bit delete, you can actually set length actually. It doesn't delete the characters, but it sets the length.
So it's the length of the string builder?
At the 34,
yeah.
If you set the length as the previous length, it should be fine, I guess. You don't have to delete it. I mean,
okay. I mean, but I don't think that changes the complexity.
Complexity, yes, yeah.
So you still think it's a NP hard? It's not n squared?
I believe so. I mean, I'm open to hear arguments against, but
well, I mean, effectively, what you're doing is you're building a bitmap, right? On the x-axis, you have the words that you have in the input set, and on the y-axis, you have the words in the input set, and effectively, by going through this process, you're doing an example of dynamic programming, where you're comparing set of strings versus themselves, removing duplicates, and for each of them, you're generating y number, which contains the bits corresponding to all the letters. So you have n squared over 2 combinations. And then you go into combining them on every single subsequent step. You're actually reducing the number of strings that you're combining. So the number of strings that are considered for combination are not exploding. They actually get reduced on each step. So the strings themselves get longer, but the number of strings that you use for consideration on each subsequent step is actually smaller.
Right. I'm not sure I 100% follow. I mean, I still think it's 2 to the n in the worst case, right? Like
Yes. Yeah.
I'm making two recursive calls here. So
yeah, every time you have branches, and there are few branches which get cut, so it's actually practically less than 2 to the power of whatever the length of the array.
But definitely we can create some example which will end up running both the logic all the time for sure, I believe.
Yes,
basically.
basically.
Yeah, imagining all the unique words.
Yes.
Then
but
like
maybe the argument may be if we have all unique care, then only it will execute everything. So 2 power 26 is the max. Even that way, maybe you can say it is constant or something, but definitely the logic should be 2 power n until it reaches the 26 character, I believe.
Yes.
Like I said, if you take a step back and say, what if these are not string, but just objects? Because effectively what you're doing is you're comparing one object with another object. And if they are similar one way or another, you're not concatenating them. So think of this, the input is a set of objects, and your task is to concatenate them in a way so that you don't concatenate any that have duplicates.
True, but for like the complexity discussion, you have to consider the worst case. So there could be some cases here where like things get eliminated and then it's like it ends up being like faster than the worst case, like exponential time. But if you consider, like, let's say if the input is like something like basically where I cannot eliminate anything, like if it's A, B, C, and so on.
Yeah.
So in this case, there's nothing I can possibly eliminate. I have to explore the whole tree that is formed by like all of these different combinations.
So the maximum length would be the worst case will be the concatenation of everything in the input.
Yes.
The length will be, yeah, the
correct.
length will be
correct.
But if you look at the backtracking, right? Like I'll have 2 calls for A, and then for each of those 2 calls, I'll have 2 calls for B, and for each of those 4 calls so far, I'll have 2 calls for C. So that's like 8 calls. So it becomes 2 to the n.
Right. So it becomes a question of an algorithm versus an implementation. So I think there was another person in the chat who said he also thinks that it's an n-squared problem. But,
no, but
you know,
he confirmed now, like he missed some scenario and he's saying he's okay with this one. I mean,
yeah, like
that's
I
fine.
feel like it's n square.
That's fine. Thank you. Great learning experience.
Yeah. So, and again, I find it kind of funny that they ask this question, because usually if you come up with a 2 to the power n solution, like you think, oh, like I did bad because like I just did a brute force. But in this case, it seems like, especially based on like the, I mean, I guess there's a little bit room for improvement if you look at the percentile here, but yeah, I highly doubt that there's any polynomial solution for this.
And one more thing is, at least by seeing this question, I was able to understand like it's a backtracking question, but I couldn't, but I have no idea like whatever you have explained, the NPP, because I'm not from computer background. So, but at least I can understand it is backtracking question, and I can, if I solve with backtracking without explaining that NP things, still that should be fine, right?
Yeah, the NP and that whole discussion is probably way outside the scope of an interview. Yeah.
Oh,
That's just like more of like a theoretical background to this. But it's kind of important because if we consider this as NP hard, then that means that we don't even have to bother trying to like think of a polynomial solution.
Sure.
Right.
Okay. Mainly, your explanation is to make sure after solving we should not feel bad since we solved by taking a lot of time. That's what your main point. Maybe. Okay. Thank you.
Yes, exactly. And I kind of feel like if you're an interviewer and you're asking this question, like it might be like I feel like it might be kind of on you to tell the person you're interviewing up front that this question is NP hard, or it can't be solved in like polynomial time.
Okay.
That's my opinion, but I don't know.
Yeah, but if you see it's a medium problem on lead code, I don't know what's their intention.
I don't agree with. Yeah, I don't agree that it should be medium. In fact, I think the next problem is actually a hard problem. But I think this, where is it?
But this problem also complexity wise it is high, but if you are comfortable in backtracking, you can solve it quickly, I believe.
Yes.
Yeah,
true.
That is the tricky.
Mm-hmm.
Yeah. Any last questions on this one?
I have one way of thinking. Maybe people have already shared that. The way I just solved it is thinking it as a combination. It is kind of creating permutations of a string where you can take every character only once. So when I designed the problem that way, it is really simple and it was easy to think through. So I was able to arrive at the solution because it automatically the recursion took care of the backtracking and everything. So I think we have already spent quite a lot of time here, but if anybody is interested, I can share my solution.
Yeah, it's always
Are
great
you thinking that will be lower complexity than this?
No, of course, because it is a permutation, so it is 2 to the power n.
Okay, yeah, sure. Okay, so and if you are planning to discuss the next question, or it's okay.
Yeah, I mean we can briefly discuss it. I don't know how far we'll get. Let's at least look at it.
Then maybe whoever discussed, maybe you can take it after this question, or else maybe you can post in our group. Is that
yes,
fine?
yeah. Whoever was talking about the permutation solution. So like in our, you can create a fork of our GitHub repository, and you can add that solution to the solutions of this session, and then Gaurav or one of the admins will like merge your solution, so it'll be part of the solution set, so that everyone can like learn from it.
Sure, I'll talk to you, Hanif, how to do it.
Yeah, sure. So last question, I don't think we need to spend, like, I think it's clear, at least the problem statement is clear. Basically, you're given us like a number, and the goal is to output a string representation of that number. Yeah, I think it's clear from the examples. So if I got this problem, I like in an interview, I probably like, I don't know. This was one problem I always like avoided until now. That's why I picked it. So I had to like force myself to understand it. But it's like one of those like annoying, very annoying problems. Does anyone have any ideas how we should solve this one?
Yeah, it's again a recursive approach, I think. But every time you keep dividing by the numbers, I think by 10 or depending on the. So first, definitely we need to have a map like an array for the ones and tens, and for others we can just directly replace. I don't know, like I have solved in a similar manner, maybe I think similar way like you did, I guess. Hanif?
Yeah. So basically, the way I think about this problem, so they say that the upper bound for the input is 2 to the power 31 minus 1. I think that's basically int max value. But if you think about the string representation for a number, there's like a pattern that emerges. So let's take this one, 1, 2, 3, 4, 5, 6, 7. So this one will be 1,234,567. And if you think about like how you even like write or say numbers, so if you take that number 1, 2, 3, 4, 5, 6, 7. So we group normally the numbers with commas with like in groups of 3, and that's actually how you say it as well. So this part is 567. This part is 234. And since it's in this position, you say 234,000. And this part is only a 1, so you just say 1 million. But I mean, if this was like 100, then you'd say 100 million, 234,000, etc. So the pattern is like you think of it in groups of 3. And then if you just think of the smallest group of 3, which would be like 3-digit numbers, like 2, 3, 4. So this is 234. So if you can solve just this, like the problem where you say, okay, you only consider like numbers between, let's say 1 and 999. If you solve that smaller problem, then solving the larger problem becomes much easier. So how might we solve the, like let's say for just 3-digit numbers?
Like you divide by 100, like 10 to the power of 2, and then you keep on reducing that. So you get 200, and I mean, there could be multiple ways of doing it, but
yeah. So if you think about the number in this position where the 2 is. So
maybe can we create a map with first values?
Yeah. So just 1 second. So like, if this is a 1, this will be 100 blank, depending on whatever is left here. And then similarly, like if this is 2, it'll be 200 plus whatever is there, up to 3, 4, 5, like for every combination. So the way that I solved this one is you have a bunch of special cases, which are basically 1 through 19. For 1 through 19, I just store in a hash map the answer. So for like 1, I have 1, 2, I have 2, etc. Because, and then same for the teen numbers, like 14 is 14. So there's no like trick, because these are like special cases sort of. So I store these, and then I store the powers of 10. So I store this as not 100, but just 100. Let's see why. This will be 1,000, and so on, for all of the powers of 10 up to 1 billion. And then like with all of these, so all of these I consider like special cases. And then basically the idea is that if I'm given 1, 2, 3, 4, 5, 6, 7, I split it into groups of 3. I solve this group. So let's say I have a function that tells me that this is 567. It's in the first, like the lowest group of 3. So this will just be 567. And then this part will be 234. And since it's in this position, it's 234,000, irrespective of anything that comes before or after. And then same thing here, this will be like 123 million. And then with our upper bound being 2 to the power 31, the highest we can go is like up to 2 billion something. So basically my approach was I I take the input number and I create an array which, so 0 will have the least significant digit. So if I had, say that number, this is, yeah, so it will be something like this. And I want to loop through this array with my groupings of 3. So since I know that the upper bound is 2 billion, like I won't have to consider like 20 billion or 200 billion or anything like that. So I just, if I see that this topmost bit is set, which corresponds to this position in my array, then my answer is like just is pseudocode. So if I see that this number is set, then I just say like answer plus equals map. So this, assume that everything here is my map of array of whatever 10 plus billion, right? So that gets rid of this one from consideration. And then I have up to 3 groups of 3 that I need to consider. So for these 3 groups, if I like loop through my array like this, like for int equals, I think it'll be 8, I greater than equal to 2, I minus equals 3. I believe that'll give me the groupings of 3 that I want when I loop through this. So I've done the 2 billion part, then the next part is this. So I'll have my ones, tens, and hundreds. So ones will be like array of I. Tens will be array of I minus 1. Hundreds is array of I minus 2. And then these are all just single digits. So I can look up all of these in my map. So then I have like string ones equals map of ones, etc. for tens and hundreds. And then there's some special cases, like if all of these are 0, then I can just continue because it'll be like something like this, which I don't need to consider. And I just build the string based on the 3-digit thing. So this is like the general structure of my code. I guess I'll actually show the code now, since we're running low on time. So I have my map. I put all of my special cases into the map. And then this is where I get my map and then I build my array. So this is my digits array. So this is like this array here. Then I have a string builder for my output. This is where I check the billion case. So that was this. So I guess this should be 9 actually. And then I loop going downwards with my groups of 3. So I have my ones, tens, and hundreds digit. And then I actually need to consider the 1 and 10 combo in case that falls in this range of like 11 through 19. So basically what I say is that if my word map contains the 1s and 10 combo, then I just directly add that. Otherwise, for two-digit numbers that are greater than 19, the pattern, like let's say if I have 54, it'll just be, let's see, how do I do this? Output out append. String of hundreds plus the, sorry, this is, yeah, just adding the 2 strings. And you see, yes. So I also have not only the powers of 10, but also like the multiples of 10 up to 100. So the 50 will come here, and then 4 will come from here. So basically what I'm trying to do in the loop is I'm trying to break it down in such a way that everything falls into one of these special cases. And then everything else that does not fall into one of these special cases, I can form as a combination. So like 54 here, I break down the 50 and I get the 50 from here, and then I get 4 from here. Right, so that'll be the ones and tens combo. And then for the hundreds place, assuming that it's not equal to 0, I just take that digit. So it'll be something from 1 through 9. So like, let's say it's 6. I take 6 and then I just combine that with 100. Right, so this will give me the like 3-digit representation. And then if I is between 3 and 5, it's actually in this position. So I have to append 1,000. And if it's in the next one, the next grouping, then that's in the millions place. So
yeah,
that's
this seems to be an iterative, right?
Yeah.
I actually implemented in an recursive way. I mean, like maybe after this I can show my
Yeah,
code.
sure. Yeah, you could do that. So does anyone have any questions on this one before we go to the recursive?
So in your special case, if it's 1 billion, then you just print 1 billion without space, right? Like on line 35. If the input is 1 billion, right?
Right, so I don't check if it's in the map directly. So I won't just return a billion. I'll take the billion is a special case. So I get that here. So if it's 1 or 2 billion, I get that from, I extract that digit, the digit in the 9th position. So I get the 1 or the 2 from here, and then I just append a billion.
But then you would have extra space, right, at the end.
Yes, yes. There's cases where I can have extra spaces.
Yeah.
So I mean, I don't know if there's a smarter way. I just did a little like regex replace for the extra spaces and trimmed the like leading and tailing extra space.
Okay.
Yeah.
I also solved this problem. Like I know this approach what Hanif told, and I solved it in a little different way, but it's iterative. I mean, I solved with the recursive as well, like a couple of years back, but iterative is something which I've solved maybe
I find maybe like recursive is little easier, but like compared
yeah,
to
I
this.
felt recursive is easier, but it is something when I try to do that after some time, I feel like I'm missing it. So the approach then I kind of I think found somewhere and then try to build on the same concept of like what Hanif just mentioned. If you want, I can show my approach. Like it is the same concept, but I implement it in a different way. If like, I'll just take a couple of minutes.
Sure, yeah, because we have a couple minutes.
Yeah, I'll directly show the solution and it will resonate with what approach Hanif has taken, but the implementation is little different. And I felt that this was little easier for me to understand. If I can share my approach. Should I share my screen?
Yeah, please.
Okay, yeah, sure. Okay, do you see my screen?
Yeah.
Yeah, so basically I did the same thing and just to, I think Hanif already called out that approach that we are dividing the problem into like group of 3, right? So if you see this particular example, 12,345. So again, in my solution as well, I'm dividing it in group of 3. Or if I take this example, I do divide it in a group of 3, right? Like this, right? So this becomes like a 1 million and this becomes 1,000, right? 234,000. So basically there are two problems to solve here. One is you convert this number into a regular like 567, right? Or this numbers to be 234, right? So that is the sub problem of this main problem. And one thing to solve, the other thing to solve here is where to put thousand or million or billion, right? That's the way it is looking for the solution. So the way I worked on this solution is that in my main function, I have a loop which only tackles the million or the thousand part, okay? And then as soon as I fix that, I just do I'm calling another function find word, which is converting 567 to 567 or 234. So the problem got divided, like this is my main function where I am splitting the total number into two parts, as Hanif said. First is just, so this is what, this is where I'm identifying by taking a mod or division by 1000. So once I identify that I have an array, so basically this, I know that dictionary is another way to solve this problem, but the way I am tackling it is that I have a solution where this particular array is used only in the first part, right? Where I keep on taking modulo by 1000 and I keep on getting my the outer, I would say the outer words. When I say outer words, what I meant is like just the numbers in terms of thousand, million, or billion. And then once I get that number, the inner number, I just call find word of and then go from there. So it's the same approach. I just implemented a little bit different. So my find word is here, which you can implement in any way, where you divide by 100 and keep on going again. So
yeah, this is also a nice approach because you don't have to use an array. So the modulo,
yeah. So I didn't
modulo
use a
1000
dictionary.
takes
I
care of that.
didn't use dictionary here. I used like an array, but the problem got like, I just split the problem in two. One will take care of like use this particular array, and then the find word will use other two arrays basically, like the ones and the tens.
Right.
Yeah.
Yeah. This is also like this. It's a very clean solution.
Good. Yeah. That's it. And any question? Okay, I'll stop. Yes.
Yeah, I guess we're basically out of time, right, Bhavesh?
Can we see the recursive solution from Naga?
I think he posted that in the chat.
Yeah, I just pasted in the chat with a playground. So maybe you can just open that.
Yeah, I'll stop the recording and